Good evening. This is my course project presentation for MIS6223, and I've chosen the topics under Group 1, which are the networking fundamentals, network types and topologies, and network models. Let's begin. Back in the day, computer has no means to connect and transfer data from one computer to another. But recent advancement in technology has made the computer to do so. What is a computer network? A computer network is a group of computer systems and other hardware devices that are linked together through communication channels to facilitate communication and resource sharing among a wide range of users. Through network connection, computers are able to share files like internet access, printers, and more. Let's discuss the components of the network device. We have the end devices or the hardware components. These are computing device that interconnect switches IP address that is unique for every computing device, such as laptops, personal computers, printers, workstations, and more. We also have the intermediary devices. Those devices provide connectivity to the network, connect individual networks, and connect segments within the same network. Let's discuss about the commonly used network devices. First, we have the switches. This is a computer networking device that connects devices together on a computer network. We also have the hubs. This is a device connecting multiple computers together and makes them perform the functions as a single unit. We also have the routers. These are small electronic devices that join multiple networks together via either wired or wireless connections. And we also have the modem. This is a device or program that enables a computer to transmit data over, for example, the telephone or the cable lines. And we also have the network card, or also known as the network interface cards. These are hardware devices that connect a computer with the network. We can see here the common data network symbols. So here we have the router symbol. This is how it looks like. We also have the switch, the hub. We have the modem symbol and the phone symbol, IP phone, laptop symbol. So here you can see all the data network symbols. What are the applications that uses a network? First, games. It allows multiplayer games between various devices. Number 2 is the databases. Networking makes it possible for different computers to access the same database. We also have the email. Sending and receiving emails is one of the important functions of network. So through network, we are able to send and receive emails. Video conferencing. This is possible because of computer networks. So if you are using your FaceTime, your Skype, this is because of the computer networks. And number 5, we have the file transfer protocol. Exchanging files over the web mainly uses network connection. So we can exchange files through the web because of network connections. Now I will show you some of the sample configuration through Cisco Packet Tracer. So now, as we have discussed about the components of the network, I will show you the examples of the different devices. First, I will show you the example of the end devices. We can have the PC. We can have the laptop. We have the server, phone, TV, and so much more. So these are the examples of end devices. Next, I will show you the examples of the intermediary devices. We have the routers. We have different kinds of routers here. Then we have also the switches, different kinds of switches also. And also we have the hub. So these are the examples of intermediary devices. I will show you the examples of the media devices. This is the auto connect. You can connect one PC to another PC using this media device. We also have the copper straight through. I'll try to connect one switch to another switch. And then we have the copper crossover. And you also have the console. So these are the examples of network devices. Now we go to the second topic, which is the networking types and topologies. Let's discuss first the local area network, or the LAN. This is an individual network that usually spans a single geographical area, providing services and applications to people within a common organizational structure. LAN usually links devices in local areas, such as in a single building, in office, or in campus. Next, we have the MAN, or the Metropolitan Area Network. A MAN usually interconnects multiple LANs. It interconnects multiple LANs. It extends over the city, and the connectivity range is up to 30 to 40 kilometers. Then next, we have the WAN, or Wide Area Network. Wide Area Network connects LANs and MANs. So it's a combination of LAN and MAN. And it covers wide area, such as the whole country. So it can cover the whole country. And the connectivity range larger than 30 miles. So it's very big. Large geographic distance. We have here the client-server model relationship. Clients have software installed that enables them to request from the server, to request and display information obtained from the server. Then the server have software installed that enables them to provide information and services like email or web pages to other hosts on the network. So as you can see in the diagram, the server is sending services to the clients. Now we discuss about the network topologies. A network topology is the arrangement of computers in a network. So you can see here different types of the topologies. We will discuss them one by one. So first we have the point-to-point topology. Point-to-point network topology is a simple topology that displays the network of exactly two hosts. Example, computers, the servers, switches, or routers being connected with a cable. The next, we have the bus topology. Bus topology is a network topology in which every computer and network device is connected to a single cable. So as you can see in the photo, in the figure, they're all connected in a single cable. Then next we have the ring topology. This ring topology is easy to manage and with low risk of collision, which makes it easy to add but reliant on all nodes being powered up and in full working order. So this is a topology that forms a ring as each computer is connected to another computer with the last connected to the first. So it is connected like this. Then we have the star topology. Star topology is a type of topology that all the computers are connected to a single hub through a cable. This topology makes efficient use of cable and it's easy to administer. But this topology requires monitoring and maintenance. Okay. Next, we have the tree topology. This is a hierarchical layout that links together groups of nodes. This topology is complicated and difficult to manage, and it uses a lot of cable. Then we have the mesh topology. Mesh topology, each node is connected to every node with a direct link. This topology creates a very reliable network but requires a large amount of cable and is difficult to administer. Wi-Fi networks make this topology more physical, so they are interconnected with each other. And we have the hybrid topology, which combines two or more of the standard topologies. This can be a good solution to create quickly linked together different existing networks into a unified system. So it is a combination of two or more of the standard topologies. Let's study about network protocols and communication. Protocols are rules that govern communication. Network protocols describes processes such as the format or structure of the message, the process by which networking devices share information about pathways with other networks, how and when error and system messages are passed between devices, and the setup and termination of data transfer sessions. Now we'll study the commonly used protocols. Number one is the HTTP, which is the Hypertext Transfer Protocol. It is a common protocol that governs interaction between web server and a web client. And then we have the Transmission Control Protocol. It handles the individual conversation between servers and clients, and not just web servers and web clients, but also the TCP segregates the HTTP messages into smaller pieces called segments. Number three is the Internet Network Protocol. It is used by routers in selecting the best path to the destination host. And then we have the multiple protocol. The message received by the host usually contains multiple protocols plus the actual data, which the application header may or may not exist. Now let's study about encapsulation and decapsulation. Encapsulation is the process to hide or protect a process from the possibility of outside interference or misuse of the system while simplifying the use of the system itself. Also makes one type of network data packets to other data types. While decapsulation is the inverse of the encapsulation process. Encapsulation is the process of wrapping the data, while the decapsulation process is a process of opening packs. Now I will show you some sample configurations about this topic. So we have discussed the types of network topologies in the second topic. So now through the Cisco Packet Tracer, I will give you some sample configurations of the different kinds of topologies. First, we have discussed is the point-to-point topology, which is a very simple topology. So we'll need one PC and another one PC, and we just connect each other to form a point-to-point topology. Next is the bus topology. So here we will need switches, two, three, four, five, as many as you want. So I will use 5 switches. So I just connect each other. Using the auto connection. Then we will need the end devices. I will use the PC. I will use some laptop also. And another laptop here. So now we connect the PCs to the switches. So this is a type of, this is the bus topology. Sorry. Okay, now let's do the ring topology. So everything is connected now. As you can see, this is the indicator. So now we'll do the ring topology. So we will need 4 switches. Okay. And then we need the end device. We need 4 pieces. So let's connect. So this is a sample of ring topology configuration. Now we do the star topology. So star topology, we need a hub and then n devices. Let's make 4 PCs. So as you can see, 4 n devices are directly connected to the hub. So let's do the connection. So this is a sample configuration of star topology. Now we do the tree topology. So I will need the switch. Okay, we need a switch here. Another switch. Let's try another one. Okay. Then we need n devices. Then we connect. Okay. This is a sample configuration of tree topology. So now we do the sample configuration of mesh topology. We need 4 switches. Let's connect all the 4 switches together. Interconnect each other. And we'll need the end device. Let's put one PC here, another PC here, another PC in here, and another PC here. Let's connect this PC. So this is an example configuration of mesh topology. Now let's do the hybrid topology, which is a combination of any of these topologies. So we can combine any of these topologies to create hybrid topology. So let's try. First, we need the switches. Okay, let's try to put one hub. One hub here. Then we need switch. Then we need another switch here. And form the ring topology here. And you have the end devices. Let's try one more piece here. And we need more switches. So let's try to connect it first. device. Okay, so this is a sample configuration of hybrid topologies. It's a combination of two or more of the previous topologies. This is the ring topology, this is the mesh topology, this is the star topology. So it's a combination. Now we do the recap. This is the sample configuration of point-to-point topology. The second one is the bus topology. This is for the ring topology. This is for the star topology. This is for the tree topology, the mesh topology, and last but not the least is the hybrid topology. Now let's discuss the third topic, which is the network models. Protocol model provides a model that is closely equivalent to the structure of a certain protocol, while reference model provides a common reference for maintaining consistency within all types of networks, protocols, and services. A network model is defined as a set of network layers and how they interact. The following are the two most important and well-known network models. We have the OSI model, which stands for Open System Interconnect, and the second one is the TCP/IP model. It stands for Transmission Control Protocol/Internet Protocol. This is also known as the DoD or Department of Defense model. We can see here the 7 layers of OSI and how the data is transmitted and how the data is received. So we'll study each layer. Layer 7 is the application layer. It is the topmost layer of the OSI model. This layer provides application services such as file transfers, email, and other network services. Layer number 6 is the presentation layer, which provides proper common data format that is sent across application layer services. The layer 5 is the session layer, which establishes, manages, and terminates connections between applications. And we have the layer 4, which is the transport layer. This defines services to segment, transfer, and reassemble data individual communications between the end devices. And the layer 3 is the network layer. This layer provides services to exchange the individual pieces of data over the network between identified network devices. And layer number 2 is the data link layer, which provides methods for exchanging data over a common media. And the layer 1 is the physical layer, describes the mechanical, electrical, functional, and procedural means to activate, maintain, and deactivate connections for the transmission and to and from the network device. Now we have the TCP/IP model. It has 4 layers. We study all the layers. Layer 4 is the application layer, which represents data to the user plus encoding and dialog control. Layer 3 is the transport layer. It supports communication between diverse devices across diverse networks. Layer 2 is the internet layer. It determines the best path through the network. And layer 1 is the network access layer, which controls the hardware devices and media that make up the network. We have here the comparison between the OSI model and the TCP/IP model. Letter A, OSI lost out to TCP/IP as the protocol suite of the Internet. The TCP/IP model is mapped to the OSI model. TCP/IP is the protocol used today, but OSI model is often used to describe network communication. As we can see here, under OSI, layers 5 to 7 corresponds to layer 4 of the TCP/IP. Translayer 4 is the layer 3 of TCP/IP. Layer 3 of OSI corresponds to layer 2 of TCP/IP, and layers 1 and 2 of OSI corresponds to layer 1 of TCP/IP. Now I will show you some sample configurations through Cisco Packet Tracer regarding this topic. We have discussed the last topic, which is the network models. In here we have discussed the two most important well-known network models, which is the OSI model and the TCP/IP model. So now we will do a sample configuration. So I will need one hub. We'll put one switch. And we need some end devices. Okay, let's wait until the color green appears. Okay, now everything is connected. Now we will configure each PC. So later on we can try to transfer some data like the emails. So this one will configure the IP address 198.168.1.10 and the fast Ethernet subnet system. Let's configure also this. Let's put this as 20. And the next PC, put this as 30, and the other PC let's put this as 40. So now we have configured the 4 PCs. Let's try to transfer one mail here and here. So let's do the simulation. So as you can see here, the file is transferring from the hub going to the other PC, going to the switch, and this one will distribute to the other two PCs. So if we click here, we can see all the layers of the OSI models. Same with here. So this is how the OSI and TCP model layers are functioning. Okay. And this is the end of my project. Next slide will be the part 2. Thank you so much for watching.